Welcome to the Explainer. We hear it all the time, right? AI and automation are changing everything. But how does a machine actually learn? Today, we're going to pull back that curtain and really get into how it all works. So let's just dive right in with the absolute biggest question of all. With all this incredible technology, how do we make sure it actually helps everybody and not just, a handful of people? You might think the answer is all about the tech itself, better code, smarter robots, but it turns out the real answer has a lot more to do with us, with people, and how we decide to weave this technology into our lives. Yeah, there's no single silver bullet here. The experts all agree that the key is for everyone to get on the same page. We need our leaders in government, our schools, and our businesses all working together to manage this huge shift. I mean, when you look at automation in the workplace, it's a real mixed bag. On one hand, you've got amazing benefits like improved safety and lower costs. But on the other hand, it creates this massive, urgent need to retrain and rescale our workforce. And to really tackle that, you first have to understand how these machines learn to do what they do. So, how do they learn? It's not magic, I promise. It really boils down to three main ways, and each one is built to solve a totally different kind of problem. First up, we've got what's called supervised learning. This is the one you see most often. The best way to think about it is like you're studying for a test, but you've been given the answer key ahead of time. The AI gets tons and tons of examples with the correct answers already labeled, and its job is just to figure out the pattern. And you've seen this in action a million times, probably without even realizing it. It's perfect for things like predicting a student's grade based on past scores, or, the big one, figuring out if an email is spam or not. It looks at millions of past examples to make that call. Okay, next is unsupervised learning. And this is, well, it's the total opposite. Imagine just dumping a giant, messy pile of Legos on the floor and telling the AI to sort them, but you don't tell it how to sort them. Not by color, not by size, nothing. It has to figure out the groups all on its own. So its entire purpose is to find hidden structures that we might not even see ourselves. A perfect example is when a company wants to group its customers. They can feed all the shopping data to an AI, and the AI will find natural clusters of customers with similar habits, without ever being told what to look for. And last but definitely not least is my personal favorite, reinforcement learning. Honestly, this is exactly like teaching a dog a new trick. The AI, or agent, tries things out, and when it does something right, it gets a reward, like a digital treat. When it messes up, it doesn't. It just keeps trying things until it figures out how to get the most rewards. This is the secret sauce behind those mind-blowing AIs that can master incredibly complex games like chess or Go. No one programmed the rules of strategy in. The AI just played millions of games against itself, learning from trial and error, until it became the best in the world. Okay, so those are the three main learning philosophies. Now let's open up the actual toolbox and look at the specific algorithms that do the work. Because when you have a real problem to solve, picking the right tool from the box is absolutely everything. So let's try a little thought experiment. Say you run a real estate agency and you have a simple question you want to answer. Is this house going to sell in the next 60 days? It's a simple yes or no question. That's a huge clue about what kind of tool you'll need. And this is the perfect way to see the difference. If you wanted to predict the price of the house, you'd use something called linear regression. It answers the question, how much? But for our problem, we need logistic regression. It's a classifier. It doesn't give you a number. It puts things in a box. It answers which one. In our case, the yes box or the no box. All right, but what about the really heavy-duty stuff? The thing we always hear about, neural networks. How does this incredibly complex brain-like structure actually think? Let's take a quick peek under the hood. At its heart, it's really just a simple loop that runs over and over again, maybe millions of times. First, it just takes a wild guess. Then it checks how wrong that guess was. Third, and this is the magic part, it uses a process called backpropagation to work backward and tweak all of its internal settings, or weights, just a tiny bit to make the guess a little less wrong next time. And fourth, it just does it again and again and again, getting a little smarter with every single loop. Okay, so we've got the theory down, but how does someone actually sit down at a computer and turn all these ideas into a program that can make a prediction? Well, thanks to some amazing programming libraries, it's actually a pretty clean 4-step recipe. You import the tool you need, you create your model, you fit it by showing it all your training data, And then finally, you use it to predict on new stuff it's never seen before. To make this super concrete, let's just walk through one of the most intuitive algorithms out there, called K-nearest neighbors, and see exactly how it makes a decision. The big idea behind KNN is basically you're who you hang out with. It's that simple. When you give it a new, unknown data point, it first measures how close that point is to every other single point it already knows about. Then it finds the K closest ones, say the 5 nearest neighbors. It then just takes a vote. If 3 of those neighbors are category A and 2 are category B, well, the new point gets labeled A. It's that simple. And that really brings us full circle. Once you understand how these machines learn, whether they have a teacher or figure it out on their own or learn by trial and error, it forces us to ask a much, much bigger question. Now that we know how to teach them almost anything, what are the things we should be teaching them?